Hi, everyone. Thanks for joining me today here on AndroidOnAir.withGoogle.com, where we're going to discuss the Google security services on Android. We've previously learned about the strength of what Google mandates in hardware, as well as how we've increased the security in the operating system. Today, we're going to cover the security services that Google puts on Android devices to give another layer of security. Now, a little housekeeping before we get started. You'll notice at the bottom of the screen, there's an area where you can actually ask your questions live, and we'll do our best to get those answered as we present. Folks from my team will be trying to answer those questions. And then also towards the end of the live stream, you'll see on the right a quick survey pop up. We really would like to have you take that survey. It's just a few questions. It kind of helps us gauge how we're doing, as well as what topics you may want to hear about moving forward. Okay, so let's jump right in. When we talk about Google security services on Android, we're talking about the services that are part of Google apps that get laid down on Android devices. We've already learned in previous sessions about the platform security and how we mitigate exploitation with mandating hardware components. But today we're going to cover extending that already built-in hardware security and operating security and putting a third layer on top of that with the security services that Google puts on Android devices. And we're going to cover three main areas. We're going to talk quickly about safe browsing, which is Google's capability within the browser, as well as other components on Android that really protect web viewing and web access. And then secondly, Google Play Protect. This is Google's mobile threat protection service that's on Android devices. And then third, we want to cover the SafetyNet components, particularly SafetyNet Attestation. And this is Google's anti-abuse service that really helps strengthen and confirm that the devices in your fleet are have not been compromised. So let's just jump right in and start with safe browsing. So to kind of give you an introduction of safe browsing, this is Google's built-in browsing protection. And a couple tidbits of information here that I think some folks don't quite understand or may have never known. These are kind of highlighting what Google's safe browsing does. Really, it protects the users from web-based threats. And those threats are things like malware, social engineering websites, phishing websites, sites that are deceptive, that try and get you to do things, it's kind of a wrapped around the social engineering piece. And then even sites that try and get you to install or craft a way to get you to install unwanted software, things like spyware, of course. The second thing is it actually warns you before you visit those sites. And what we're going to talk about here in a few minutes is, as an IT admin, how you can actually control some of these things. But it also, what people don't understand or don't really realize is that it actually identifies dangerous links within Gmail messages. So whether you're using the Android Gmail client tied to an Exchange backend, it still sees those links and will prevent or protect users from opening those links on Android devices, even if you're not using the server side or Google's email service. The Gmail client itself looks at those links and identifies them. It's also super wide and very well deployed. It protects over 4 billion devices every day. And what it's kind of important to highlight that Chrome is not just on Android. It's on every operating system or major operating system today, including Mac, Windows, Linux, iOS. So it really is a pretty wide service that protects users when browsing the web pages. The other thing it does on Android is it extends protection into WebView. And we've talked about this in one of the previous sessions, but WebView is a component that allows web content on Android devices and other operating systems to actually be displayed within an application. And in the past, several years ago, that was an attack vector that bad actors would try and use to get access to web components through WebView. And now that safe browsing actually extends into the WebView. And then finally, this is a part that I think people don't really realize, is that not only does it help the user, it also helps webmasters and website owners, because it also notifies webmasters and operators of sites that their site may have been compromised. We're learning more and more every day that legitimate sites have been compromised to try and inject like a phishing technique or piece of malware or unwanted software without the web admin even knowing. And as we find these sites, we actually notify the web admins and we give them guidance on how to fix it. Now, if you are curious, the link at the bottom of the page, I know it's long. This site is a safe browsing search capability. So if you want to plug in the URL of a website to see what safe browsing sees that site as, you can see what Google has, whether it's either safe or what is identified on a particular website that may be kind of trying to insert malware. The other thing I'd like to give to you is, what does safe browsing give the enterprise? Like, what can you do to control it? So we kind of know what it is, but being able to control it is even more important. It's no good if a user can disable it. It's no good if a user can store passwords. It's no good if you can't define parameters to control safe browsing and to control Chrome. So there is a website, you can see it here, where you can view all the available policies for controlling Chrome policies. And there are just hundreds of policies that you can apply to Chrome. And the most important one is obviously to disable Chrome's safe browsing. You want to prevent users from disabling it. And some of the other common policies that we see that enterprise customers enable in Chrome is disabling incognito mode, right? Because that prevents certain things from happening, that where users can visit sites without you knowing, and then potentially inject something onto devices. You also, like I mentioned earlier, you want to prevent users from disabling safe browsing. So you can actually do that. You can define proxies. You can send down pack files. You can also set whitelists and blacklists so that users can only visit specific websites, or you can prevent them from going to certain websites that you put in. And there's also wildcard support. So it's very powerful. And one of the other ones I see enterprise customers use very often is disabling the ability for a user to save passwords in Chrome to make it easy for them. You may not want to do that on a mobile device. It's just one of those common policies that I see enterprise customers turn on. And then on the right-hand side, you can see like a description of safe browsing from that website there at cloud.google.com/docs Chrome Enterprise Policies. I know that's a mouthful, but this is an example of what you would see and the capabilities that you can enforce. And this is just an example of the safe browsing enabled, where the user cannot disable it. Now, moving forward, this is an interesting statistic, and you can go to the transparencyreport.google.com safe browsing overview and see over the course of time safe browsing history and what we've seen. And you can see in this trend, and we've talked about this earlier when we talked about malware on Android, that over the course of the last few years, malware on Androids has gone way down and phishing has gone way up. And you can see this even in safe browsing from the trends here. The red is representing phishing sites and the blue is representing malware sites. And you can see exactly that. And this is a bi-week report here that you can actually go look at yourself. And you can see how many bad phishing sites are actually detected every week. In the week of March 8th, 37,000 websites. 37,000 websites were found to be phishing sites. Now that's per week. So there's a lot of bad things happening out there. So you want to make sure you control safe browsing for your users, not only to protect them, but to protect your fleet of Android devices. Okay, so Google Play Protect. This is Google's mobile threat detection service. It is the most widely deployed threat detection service on Android today. It is on 2.5 billion devices. Those are devices that are checking into Google every 30 days. And Google Play Protect actually scans roughly 50 billion apps every single day. That is a ton of apps, and those can be on devices. Those are devices that are there. They're apps that are installed from third-party stores and as well as from unknown sources. So it's not only apps that come on the device pre-installed, but also apps that are installed by users outside of Google Play. In fact, the PHAs, or what we call potentially harmful apps, Google actually scanned or stopped 300 million installations last year from on offline scanning, which means the device wasn't actually connected to the back end. So that shows the power of the capability of Google Play Protect, even when it's not connected to the back end Play infrastructure. When it is, and when it does connect back to the infrastructure, it does integrate deeply with the cloud-based components, where application updates can be pushed directly down to devices. This is super powerful because if we find a potentially harmful app or piece of code in one part of the world, very, very quickly, we can actually push an update out to those 2.5 billion devices very quickly. And it's also important to understand that the scans are done before installation. It's not that the apps are installed and then scanned in a running capability. They're actually scanned before they're installed. It's also important to understand that private apps that you build for your organization. This is we have a very strong privacy-centric view of that. So these private apps, it's not that we're looking for your proprietary code. We are preserving your private information. In fact, the whole Play infrastructure is ISO 27001 certified. So that gives you comfort knowing that we adhere to those standards that are recognized globally to protect your private data that may or may not be associated with your private apps. It's also important to know that we scan PHAs that get installed from unknown sources as well, not just apps that come from third-party stores, not apps that come from your EMM or your carrier. If a user enables unknown sources, that application is also scanned at time of installation or as it's getting ready to be installed. So it not only does legitimate installations, it does installations, scans apps installed from unknown sources as well. The other thing that it does is it actually scans, and it will automatically do this on a daily basis and remove or disable those apps so that they can't be run. Depending on the classification, which we'll see on the next slide, of the different types of PHAs that Google classifies these apps as. And then finally, a user can actually do an on-demand scan, right? So they can actually go into the Google Play Store or Google Play Services on a device, and they can initiate a manual scan. And they have complete visibility to see, what's going on and what the scanned apps look like, if there were any harmful ones. And then finally, here's the most important part. We have APIs for the EMMs to query every single device. And those APIs are part of the Verify Apps API. So the EMMs can get a status of what the Google Play Protect service on that device feels the status is for any potentially harmful apps. Now, controlling Google Play Protect is pretty straightforward. We can basically ensure that the user does not disable Verify Apps. That is what Google Play Protect really is. It's ensuring the apps are scanned. So with an EMM policy, you can ensure that Play Protect is always on. You can also scan a device or call the API as an EMM and get a list of the PHAs of the device, or the PHAs that are on a device from the Google Play Protect service that's running on those devices. And then you can use compliance. So if your EMM has compliance capabilities, you can use the compliance to remediate. For example, if a user installs something that that is considered a mild PHA, and I'll show you the categories here on the next slide, I believe, is that you can determine based on your compliance whether you want to remediate and make the user remove that app before they can gain access to work data again. So it's a very powerful API that you can use. The second thing is that mobility admins have the ability to submit potential PHAs that they find. So for example, a security team may want to allow a particular app from a particular source and they want to check it. Fine. They can actually submit an APK to Google for a deep scan as if they were to upload that APK for deployment in the regular Google Play Store, right? So that's a very powerful tool that is available to admins. Third thing is, what if you build a private app and you don't necessarily need all the consumer controls around that app, and for whatever reason your private app gets flagged as a potentially harmful app? You also have a way to submit to the Google Play Protect team to whitelist your app for only your domain when it's deployed privately to your organization. So this gives you the ability to have Google Play Protect in your organization not see that as a potentially harmful app. However, it still must meet the requirements. It just gives an enterprise the capabilities to denote that this private app is legitimate for your domain. And then finally, we also know that, and we previously mentioned that you can disable installation of applications from unknown sources as part of the API in Google Play Protect, Google Play. Now, very quickly, well, I'm not going to read all these, but these are the PHA categories, or potentially harmful app categories, that Google places all these bad apps into. So whether it's in ransomware or commercial spyware or some of the other unwanted software categories like click fraud, data collection, or impersonation, all apps in Google Play and even apps that are scanned on the device itself will fall into one of these categories. So you'll have a better understanding of your private apps. For example, if it gets flagged for impersonation, most times it's as simple as Google Play thinks that you don't own the app and maybe you've used a name of a registered trademark, for example. So it's very robust in what it scans for. Now, the final thing we want to cover today is SafetyNet. The SafetyNet combines several different capabilities. The one I'm going to talk about today is SafetyNet Attestation. And as a whole, SafetyNet is Google's anti-abuse service that lives on Android devices. And if you've listened to my previous recordings where I mentioned that Google places an attestation cert in the hardware of all Android devices, we provide that attestation key to OEMs to inject at time of manufacture. This is the key of how we protect SafetyNet calls. And what it does is it helps determine whether your private app is running on an uncompromised device. So for example, if you deploy an app, you can build in SafetyNet components to ensure that your app won't run on a compromised device. It will not run on a compromised device. An example of that is Google Pay. The Google Pay app will not run on a rooted Android device because it sees or thinks that that device is compromised. It uses a very strong cryptographically signed attestation to safeguard the attestation call to Google, and we'll cover what that looks like in a moment. But what it does is examines the device's software and hardware environment, and it looks for very specific integrity issues. And then it compares that with a reference model that Google already has. So for example, if there's a Samsung or a Pixel or Motorola device and the attestation call is done against that device, Google knows what that particular device is supposed to look like when it leaves the factory floor. So if anything changes on that device, whether it's something in the system partition, the bootloader is unlocked, and there's many other things that it looks at, it can then say, okay, my reference doesn't match what the SafetyNet service has sent to me. So it can kind of then determine something's not right. The bonus here is that recently, and it's rolling out today, and you've seen some blog posts on this, is that key attestation on devices that ship with hardware-based key attestation, that's basically Android 7.0 or API 24 and above. Google SafetyNet actually now can detect something that used to be able to hide, which was Magisk. Well, I know that's a very big concern for a lot of organizations, but Google Key Attestation added to SafetyNet now can detect Magisk on devices that are BYOD brought into in an organization to protect even on BYOD devices. The chart on the right you can find at the SafetyNet site at google.com. It just basically shows the two types of profiles. One is CTS profile match, one is basic integrity match, and what it actually looks for. So you can go to that website and look at that at your leisure. So real quick, I want to just step through the flow here so that you understand how SafetyNet attestation works. And again, this is how an Android enterprise customer using a partnered EMM can use SafetyNet to use compliance to actually stop a user from using a compromised device. So it's very basic. You see the representation here. So number one, the EMM policy controller on a device will get a signal from the server that says, hey, I need this device to do a SafetyNet check, right? So that signal comes from the EMM agent and it goes into the SafetyNet service. The SafetyNet service evaluates the device in runtime. It looks at the environment. Remember, it looks at the software and the hardware. And then it requests an attestation from Google server. So it sends that information over, signed, so that the Google service knows that it hasn't been spoofed. And then the SafetyNet attestation server sends a signed attestation answer back to the on-device attestation service. All right. And then the attestation returns that signed attestation result to the EMM agent. And at this point, it will be nothing more than a simple pass or fail. At that point, the EMM agent then can tell the server what has happened for reporting capabilities. And then the EMM agent then can enact either automatically or on a signal from the EMM server based on the policy that was already on the device, what to do if the device comes back as failed. So if it comes back as a pass, obviously there's no action. But again, EMMs that use compliance engines can use that answer as a way to mitigate and remediate, to get a user to remediate and fix whatever issue may have caused this. So again, super powerful tool to help you maintain the integrity of your Android fleet. And I would say most major EMMs now support the SafetyNet attestation call. Check with your EMM vendor to ensure that that is a capability for you. Finally, let's just summarize very quickly. We learned in earlier sessions that the hardware now is required to be secure. We layer a very secure operating system on top of that with all the mitigations. And today we covered 3 really strong Google security services that protect Android even more. It's layers. First, safe browsing protects users and admins or organizations from social media, malware, or unwanted software from being injected onto a device through any type of web browsing capabilities in Chrome and WebView. Google Play Protect, the most widely deployed mobile threat detection service on Android today. 2.5 billion devices protected, constantly learning, even can scan system apps at time of installation from an OTA update. And then finally, SafetyNet attestation, Google's anti-abuse service to assess the status of Android devices. This is super powerful to protect your Android fleet of devices and integrates very nicely with the partnered EMMs that can manage Android enterprise capabilities. You can get more information about each one of these services on the links below that you see here. I want to thank you for joining our session today here on Android on Air. If you want to find more information around these topics, android.com/security and android.com/enterprise. And we're going to keep this web session running for approximately another 5 minutes, where we're going to keep trying to answer those questions that came in. If your question is not answered before the end of this live stream, please come back in the next day or two to view this on demand. And you can very quickly go to the bottom of the on demand section and see that all the questions that were asked will be answered in that time frame. It may take a day or two, but please note again that if your answers are not there during this session, they will be posted in the on-demand view. Thanks again for joining me today. Stay healthy.